Hey everyone, thank you so much for all of you for joining now. And I'm really excited for today's session. But first of all, I would also like to extend a heartfelt gratitude to Shivay for coming over here. Shivay, you can just unmute. And thank you so much for coming over here. It's an absolute pleasure for the whole Hackathon team to have you.
Yeah, thank you so much, Krishi, and an entire my proudest, thanks to the entire team at Hackon who have been doing an amazing job with Hackon 2.0. Being an organizer myself, as one of the organizers for Hackon 1.0, it was like a unique challenge that we had been part of with the pandemic going on and being probably India's one of the first virtual hackathons. And this time, with the amount of coverage and the amount of impact that we have been able to create by delivering such wonderful, amazing sessions by other people who have given so far. It's just an honor to be, presenting today for Hackon, and I hope that with this particular experience, everyone who are dining in today are able to learn something and they're able to implement that during the hackathon itself. Because as the hackathon, the themes this time are much more, focused towards providing a better lifestyle, and like, let's say, related to the pandemic, or it's about global diversity. So all of these are very relevant social causes, and I just hope that, because machine learning is something that can help with a lot of that, to be able to use machine learning and implement projects that can really help the society. I guess that is the ultimate takeaway that everyone should have from this particular talk. So again, yeah, thank you so much, Krishi, for inviting me over for Hackon.
Thank you so much. And I'll just quickly go over and I'll quickly introduce Shivai because he's also the GSOC Google Summer of Code mentor at TensorFlow. And the rest I'll leave up to him to introduce himself because it's a long introduction. He has been one of the most collaborative member amongst the communities. And today's session is also very interesting because it's going to be something about introduction to TensorFlow and TensorFlow.js. So Shivai, I'll leave the stream to you and
Yeah,
hope you have a good
absolutely.
time.
Yeah, so let me actually share my screen as well.
Sure.
But till then, yeah, just to not waste a lot of time, as Krishi has already introduced me, so I am Shivai. Hi, everyone. So I specifically, I'm a Google Summer of Code mentor, and I have been involved in a lot of different open source projects, but specifically something that is really dear to my heart is the TensorFlow community as well. So this year I'm going to be contributing to the TensorFlow community by being a Google Summer of Code mentor with TensorFlow and MediaPipe. That also is a subset of TensorFlow. Both are open source Google projects. And last year I was a Google Code and mentor with TensorFlow, and also a Jenkins Google Summer of Code mentor for the machine learning plugin. So a lot of my work has been into open source machine learning, and also in general related to web technologies. So that is why we are going to be talking about two of my personal favorite things that I really love in open source, and also from a community aspect as well, where I'll be also describing how can you also join these communities and kickstart your career in machine learning. And if also if you're interested in specifically, like, let's say, related to TensorFlow, deep learning and all. So I hope, like, with this particular presentation, everyone is able to get that. Anyways, without wasting any further time, let's quickly get started, right? So I'll quickly bring up my presentation, right? So give me just 1 second. By the way, if anyone has any questions, Kushi, like, we can make it really interactive. So I would pause probably in between after picking up one particular topic, and then we can go over those as well. By the way,
Definitely.
yeah,
I'll keep you updated.
sure. Thanks a lot, Christian. So the first question that, because these are very heavy words, right? TensorFlow and TensorFlow.js are very heavy words. So I didn't want to dive deep too much into machine learning, because if I take a session just on machine learning, that will be a completely new and dedicated session in itself. But just for everyone, right? For everyone's, insight on what exactly is machine learning, right? If in case you don't know that. So machine learning is a technique that helps, find out patterns in data, right? So whatever kind of data you might be having, you might be having images of just cats and dogs, or you might be having data of numbers, right? You might be having, let's say, some handwritten drawings of numbers, and your task is to actually classify what is the number that is there in that handwritten drawing, that digit you have to classify. So the idea is that whatever data that you get inside of machine learning, the machine learning algorithms or the models, they're able to infer the patterns and infer information about the data, right? And based on that inference of and the observations that they make on top of the data, the patterns that they're able to find, they're able to make certain predictions based on those patterns. And we use machine learning in probably almost all the different major sectors today, right? Whether it is like society, like healthcare or education, you'll find machine learning being used in each and every different sector of our life that we can think of, right? So machine learning today has become a very, very important tool. And just to give an analogy of the main difference between, let's say, a program that might have been written in like, let's say, simple, C++, right? So you give some input, you give, okay, I want to do, like, let's say, an addition operation on that. You will get an output, right? So you do 3 and you give the input as 5, and you give the operator as plus sign, you get the output as 8. But in machine learning, what happens is that instead of getting the operator, you would be asked, like, you'll be asking the machine to actually predict what exactly is that output, right? So for example, let's say you give the input as 3 and 5, you give it an output as, let's say, 8, and then you tell the machine to actually predict what exactly is the exactly is the operation that is going on. So based on a certain number of data that it interprets, it is able to provide you an information that, okay, the predicted operator might be a plus sign, and with that you're able to make certain more predictions. So that is the major difference between both a standard programming and a machine learning based programming, right? So keeping that in mind, we also have something that is known as TensorFlow. So TensorFlow is a free and open source machine learning library that was created by Google, that specifically is helpful for a lot of applications, such as neural networks that are again that comes under the deep learning aspect. And again, for those people who might not be aware of deep learning, it is a subset of machine learning that usually behaves how your human brain actually behaves. So it is synonymous to the structure of how neurons work, and we use that same kind of an application of neurons into the development of neural networks as well. So the idea behind and why the reason TensorFlow was actually introduced was that with more and more data, right, we had to do a lot of calculations, and this involved a lot of different numerical calculations, right? So earlier we used to have these very popular Python libraries like NumPy. So NumPy is also very popular library for doing a lot of statistical and numerical data, right? So numerical analysis on data. So but the issue was that as the data became more and more complex, you had data ranging in gigabytes and terabytes of data, as like the social sites grew, and like people using the internet, and this data in itself just grew a lot because a lot more people were using and accessing data, right? And machine learning was being used in a lot more other places as well. So it was that the NumPy was not able to actually catch up with such kind of huge complex calculations, and that is why there was a need to introduce a much more much more advanced version of NumPy. And that is why TensorFlow is also primarily a mathematical library, and you'll find a lot of mathematical calculations going on inside of TensorFlow. But the level or at which number of calculations that TensorFlow can do is way higher. And when it comes to production grade systems where you're having data calculations in gigabytes almost every second, TensorFlow is much more efficient in terms of providing that. And of course, it is also providing you things like differentiable programming as well as part of its applications, right? And this some general facts about TensorFlow was that, as we described, that originally it was built, right, to be able to actually run these numerical computations, right? And these data, like usually the data that we actually store is stored in these multi-dimensional arrays that we call as tensors. So as you can see, right, like the word TensorFlow is broken down into two halves. One is the tensors that basically describe how and in what format the data is being stored, and then the second word is flow, that is basically how that data information is now flowing. So basically these multi-dimensional arrays, right, these are storing the data, right? And all the calculations are happening by manipulating this data. So whatever like kind of transformations you have, because when it comes to machine learning, we have a lot of different mathematical tools that we can use, right? We can use things like Fourier transform. We have different type of transforms that transforms our data from one type to another, right? And we do a lot of these calculations in these huge matrices or these arrays with higher dimensions. So not just one dimensional array. It could be like n dimensional arrays that we're looking at, right? So that is what our data is accepted as, or our data inside when we're using the TensorFlow library. Our data is represented in the format of tensors, and these tensors, like the flow of how these information or whenever the calculations are taking place from one tensor to another, right, that actually happens with the help of these data flow graphs. So in case you are a computer science student or you are still studying, right, you must have heard about graphs and the concept of nodes and edges, right? Like graph is a data structure that helps a flow of information with the help of these nodes, right? And from, or these, basically these nodes, or we call them as edges, right? So these edges help to actually transfer the data from one node to another, and they are connected with each other to help with the transfer. So similarly, in terms of how the data is actually flowing, right, that numerical data, and because at each and every different step there are certain mathematical calculations taking place. So how that data is being transferred from one one, let's say, one segment of your overall architecture that you have built using TensorFlow, how that is transferring, that is controlled with the help of the data flow graphs. So you can study more about like how tensors work, and we also come on to that a bit later on, and how like the data flow graphs also work, right? But essentially this is how, like all the different calculations that take place are with the help of these inbuilt tensors that so tensors are like the building blocks of any TensorFlow project that you build, and tensors are the way in which we are able to represent our data, right? Similarly, for example, in terms of let's say a building block of for water, like like for the ocean, it's the each drop of water, right? So similarly, you can take that analogy over to TensorFlow as well. That the tensors are the ultimate analogy, right? For when it comes to being able to use huge computational data. And again, TensorFlow is very well optimized for running such kind of optimizing. And today we are also using TensorFlow in a lot more other aspects of AI and machine learning. As we described that earlier, it is just meant for those mathematical calculations, but we are now using the applications of TensorFlow in a lot of other areas as well, like computer vision, NLP, right? And it's becoming actually quite popular in all of these different areas as well. So if anyone has any questions related to TensorFlow, and we'll also be overlooking some of the great resources to actually get started with TensorFlow, and some ways in which you can also get a part of the communities in TensorFlow as well, to learn and to be able to connect with the right kind of people who are in the TensorFlow community, and to get the great learning resources that are needed. So that sort of
Why, just
yeah,
to
yeah,
interrupt,
Khushi.
you were asking about questions. So we just have one question until now, which is more
Yeah.
about, will we be using TensorFlow 2.0?
Yeah, so right now the latest version of TensorFlow, so TensorFlow 2.0 was released, if I'm not mistaken, in early part of 2020 or late 2019. I'm not exactly aware of the release date, but today, right, most of the applications that you'll see and support is there for TensorFlow 2.0 and above, right, 2.x that we say. So recently there was release for TensorFlow 2.4 as well. So like, of course, it's not that you can not use older versions of TensorFlow, but there's still there's still like the latest versions and the latest documentation that you'll see will be based on TensorFlow 2.0 and above.
And we have another question as well, and this is from Harshvardhan. So he asked how to get started with TensorFlow.
Yeah, thank you, Harshvardhan. So, of course, like we'll also, look at some of the learning resources, and just a quick introduction on how to get started with TensorFlow very soon. So, as we move in this presentation, I'll also, provide the resources for that. And for that, I'll quickly just again share my screen. So, if you can provide,
Yeah.
Khushi, you can. All right. So, see, basically the learning path, right? The learning path on how to get started with TensorFlow, right? That is probably the and the most common questions that everyone has. So see, one of the most important things to note is that TensorFlow is more on sort of an advanced concept when it comes to learning this TensorFlow. So before you start with TensorFlow, some things to keep in mind is that you need to be aware that you need to be proficient at least in some basic machine learning concepts. Now that could be like learning at least some basic machine learning algorithms, right? And learning mathematical tools, for example, statistics, linear algebra, because these are actually quite common when it comes to concepts related to TensorFlow or any other machine learning algorithm. Whenever you are building any machine learning algorithm, concepts of statistics like variance, covariance, probability, all these different these mathematical tools, statistical tools, they come into the picture. So having at least a decent basic understanding of these mathematical tools is also important. And of course, if you know like a programming language, at least one programming language like Python or Java, because TensorFlow actually has support for a lot of different projects, because TensorFlow in itself is a very, very wide project, right? There's the basic TensorFlow API, right? But then there are a lot of different other projects that are under TensorFlow. So make sure to make yourself proficient in these particular concepts, right? At least get started with these concepts before directly jumping onto TensorFlow. That would be my first aim. And then of course, then that is a process when you start learning TensorFlow. So the TensorFlow official TensorFlow website, that is tensorflow.org, that in itself has a lot of learning resources. But if you like to watch video tutorials, right? One of the best ones are available on Coursera. I'll be just also sharing the links with everyone for that. So basically on Coursera, the team at TensorFlow has specifically designed coursework that has multiple levels. So Lawrence Maroney, who is one of the lead development advocates at Google and one of the lead researchers at Google, he has built those particular concepts, and they go on out from starting from scratch with TensorFlow, how to understand the TensorFlow API and go all the way to creating really great projects as well. So that way you can get started with TensorFlow as well. But usually, again, as with any machine learning project, you have to implement as you learn, right? So you can take up courses like these courses, right? But you also need to implement them in projects as well. So take up relevant projects and implement whatever you learn with regards to TensorFlow. And if as you go deeper into different concepts, do make sure that you also try to use them in those machine learning projects that you're building. So that is like one of the points that I would like to give. But of course, we'll be going deeper into the different resources as we move ahead in a bit. So I hope like that answers the question. Are there any other questions? Question?
So we do have
I'll just keep in mind, if there are any questions.
Sure.
So
We have one other question, and which is
yeah.
for TensorFlow for like TF.js to
Yeah.
learn and contribute in. Is it necessary to ace in JavaScript?
Yeah, so Anshuman will be coming on to TensorFlow.js also very quickly. But of course, with TensorFlow.js, it is necessary to at least know the basics of JavaScript, because the code that you'll be writing will be in JavaScript. But again, you don't need to be like a master in, like in JavaScript. Even if with basic HTML, CSS, or any other framework that you can use in JavaScript, even if you do know the basics, you can use TensorFlow.js as well. But you do need to know basics of JavaScript to be able to contribute to it.
Awesome. I think we have questions until this one, and I think you can just go on with the stream, and then I'll just update you if we have any other questions.
Yeah, absolutely. All right. So coming back to the TensorFlow, right? So see, originally it was created as one single library, right? And that library is written in C++. So the original TensorFlow library that we have, it has been written in C++. And the idea is that because TensorFlow has really huge support, there are a lot of different TensorFlow projects that that are actually there. So we have things like the TensorFlow core. Now, the TensorFlow core is your main API, right? The TensorFlow API that has been written in C++, and that is one that basically describes all the mathematical internally. It has all the mathematical calculations that take place for the data flow and all, how the tensors are being represented, right? So that is what is comprising the main TensorFlow core. Then we have support for TensorFlow for all the different major languages like TensorFlow.js, that is the TensorFlow support for JavaScript to be able to directly write TensorFlow models in JavaScript. Then we have TensorFlow Lite, that is specifically for low-powered devices, and it has support for both Android and in iOS as well. Then we have TensorFlow Swift, that is exclusively, right, TensorFlow for Swift programming language, right? Then we have the TensorFlow Model Garden, that provides a list of various models that you can just use and directly get started with those models. And then we have Magenta, that is uh, TensorFlow for music, basically for music generation, music synthesis. And these are just a few of the projects. We have TensorFlow Quantum for quantum computing and using neural networks in quantum computing. So you can see that TensorFlow is a very diversified field, right? TensorFlow is not just like an library today. TensorFlow today is like an entire organization itself, right? And a community, and it has a lot of different projects, right? Right from the core API from which it actually started originally, and of course, then these APIs have in Tune, they have also modernized, and you have specifically now APIs and that you can like a dedicated library for Python that has been built on top of the C++ core API. And you also have things like other libraries like Keras that have been built on top of TensorFlow itself to provide you even more easy access to actually use the power of TensorFlow. But in case, of course, you want to use TensorFlow at its core, right, you can always use the core API as well. So those are some of the major projects from TensorFlow. And I would like to specifically dedicate some time towards machine learning in JavaScript, because I guess that might be the most relevant thing right now. So one of the first questions like why it asks is why use machine learning in JavaScript, right? Because see, today, as we said, that all the different businesses are going online, right? So the first question that comes to everyone's mind is that why to actually learn, or why to implement machine learning in JavaScript? Because every business today has an online presence, right? So a lot of the businesses that relied on machine learning softwares, let's say in person, now everything is virtual, right? And virtually you are connecting it via, let's say, your mobile devices with apps or with the websites. And today more and more websites are implementing machine learning to be able to actually use machine learning based applications in their web apps. And things like, let's say, recommendations that you get on YouTube, product recommendations on Amazon, things like facial recognition that you might be using to get into your smartphone or validate a purchase, right? So there will be a huge number of applications that are possible with machine learning in JavaScript, because JavaScript is a very versatile language. And the idea is that because we can use JavaScript on almost each and every different platform that is out there. So browser, you can use it on common browsers like Chrome, Swift, Safari, or like Mozilla, right? Any other browser, like, because every browser has native support for JavaScript. Then you have the server side. If you are creating a server application, so you can have things like Node.js that enables you to actually create JavaScript on the server side and then create those web-based applications, right? Then you have the mobile, where you have cross-platform application support via React Native. We have PWAs, that is progressive web applications, that run on both your web application, like on your browsers, in the laptops or in the computers, but also on the mobiles. Then you have ability to create desktop applications using Electron.js, and also you have and literally use JavaScript within IoT also via creating a node-based Raspberry Pi backend. So it has support on all these different categories. And just considering that if you're able to implement machine learning in JavaScript, we are able to reach out to all these different platforms and introduce machine learning based applications in all of these different platforms as well. So that is one of the major reasons. And another one is that because a lot of the professionals, and like TensorFlow.js, when it was originally created in 2018, it was announced in 2018. It was specifically also for core JavaScript developers, because a lot of creative designers, who are not really having a lot of experience with core fundamentals of computer science, but they might have learned JavaScript as a programming language to represent their work or their artistic work. They might need to actually learn an additional language like Python, and deploy machine learning models in Python and use those with their applications. So that was one of the major hurdles before 2018 when TensorFlow.js was introduced. That in case, let's say, if you wanted to have a machine learning based application inside of your web app, you need to have a dedicated server written in, let's say, Django or Flask, in which your machine learning model written in Python used to be hosted, and that way it would communicate with your main web application. So that was an additional step that had to take. But with machine learning in JavaScript, you don't need to create, like, you don't need to learn additional programming languages like Python to be able to actually host a machine learning model, because the machine learning model can be hosted directly and written in JavaScript. So that is another reason why JavaScript machine learning was introduced. And basically, the JavaScript, like TensorFlow.js specifically, provides us three major ways in which we can create models, right? Or we can utilize machine learning in JavaScript. So the first one is, the pre-existing models. So these models are pre-built and they are, pre-packaged in JavaScript, and you can directly just use them in your application. So without, having access to, let's say, knowing, okay, what exactly is machine learning, you can still actually use it. You don't even need to necessarily know what exactly is machine learning, for that matter, right? So you can use things like the pre-built models, and these are, for beginners who might not have even any specific knowledge about machine learning, right? And you can get started with these. The next type of them is retraining the existing models. So this specifically uses a concept in machine learning called transfer learning. Now, what exactly happens in transfer learning is that you give a pre-built model your own data so that it can modify itself based on your own data. So basically, there's a retraining process that takes place on an existing model, and you're able to sort of train that model based on the input data that you have, and then you'll be able to actually use that modified model for your own application. So basically, there is a support for transfer learning as well. And of course, you can write your own custom models directly in JavaScript. We have certain APIs that are provided by TensorFlow.js that help you to do that as well, without, like, any external dependencies on using a programming language like Python as well. And of course, like, because we are going to be talking about JavaScript, right? So JavaScript in itself is a very versatile programming language, right? And you can do things like augmented reality, sound recognition, and literally anything in web, right? And that in itself provides so many different capabilities of using machine learning in all those different applications. So that is why whatever you might think of, you can actually use TensorFlow.js in that application with the help of JavaScript, because JavaScript being so versatile. And first, we're going to be, talking about the pre-trained models. Again, like, these are, simple 10 lines of code that you can use in your project and create really interactive and really creative applications in TensorFlow.js. And we have a lot of different, models that are there for TensorFlow.js that are available to us. And these are, just some of them. So some of them most important ones that we have are related to image classification, object detection, body segmentation. These are all different, very popular machine learning based applications that we do. And some of the popular examples include, like, the Coco SSD models that are very popular for object detection, for example, right? So that helps us to use directly these models without any help, right? And of course, there are new models that are being added. Just recently, we concluded with the Google I/O, where a new model was also released that is actually, based on top of the Pose net model that we had. So again, there are new models coming in and optimizations being made. So you can use models that are related to computer vision and all the way to, let's say, neural networks. For example, we have the text toxicity one that is able to do things like sentiment analysis on Twitter data, for example, and then we have some classical machine learning algorithms as well, having support in TensorFlow, just like the KNN classifier. And if you want to check out all these different models, you can go to this link that is tensorflow.org/js/models. And over here, you can actually go to any of one of these code. For example, let's say we want to go to the object detection model, right? And we click on view code. So you can look at the readme over here, and you can see that it's actually very simple to load these models via either like the script tag, or if like let's say you're using React, you can use like the npm package. And if you look at the code base, right, we'll be coming on to that very simply. And you have things like the functions like dot detect that usually would require to actually write 100 or 150 lines of code in if you're creating a machine learning model from scratch. So these models are there for you to use, and of course we'll just talk about these very quickly and as we go towards a code demo. But you can find a lot of these pre-built models over here, and of course if you explore more on GitHub, you'll actually find a lot more than the ones that are provided. You'll find all of these different ones that are represented over here as some of the pre-built models that you can have a look at, and you can start using them very easily, right? And of course, if you are thinking about using machine learning in this hackathon, the upcoming hackathon, and you don't have a lot of experience, or your team does not have a lot of experience with machine learning, you can actually do have a look at any of these models and try to implement them in your project, and see if your that particular application of that model does help with your project as well. So very easy to get started with, and I'll just give a very quick demo for one of them as well. So these are some of the pre-existing models, right? And so you can quickly get started with them. Now, some of the examples that I've already given are the CocoSSD. So CocoSSD is a very popular object recognition model. And in TensorFlow.js, we give almost 90 different classes. So things like cars, humans, animals, different type of animals. So what it does in this particular demo is it provides like an image of a dog, and it is able to create a bounding box in front of the dog and predict that okay, it is a dog with a 98% confidence. So similarly, we have all the other ones like face mesh. So this basically points out all the different coordinates on your face and is able to create this facial construct of your entire face by taking points, right? So there are these facial landmarks that you see, these points that are there. So there are a total of 468 facial landmarks through which the machine learning model is able to understand where exactly is your nose, how is your mouth acting, and it's just 3 megabytes in size, a very optimized model. And we are also seeing it live in production use by these companies, like for example L'Oreal, which uses them in their mobile application for example, let's say in the lipstick one. So they're being used in production right now as well. So very popular models and very optimized. So if you have certain applications that you are willing to think about creating, like let's say understanding the facial expressions of a person by monitoring their facial expressions to understand what are they going through. Are they having, let's say, some like are they having depression, for example? So you can do that with the help of the face mesh model as well. And then we have like body segmentation that is able to uniquely identify your body, and it can actually do across multiple bodies in real time as well. So it can uniquely identify if there is a human body inside of a background. Again, body segmentation can be very helpful for, let's say, creating applications that are where you only want to interact with the main person in sight and not with any of the additional backgrounds. So you can think of various applications for that as well. And of course, with a little bit of creativity, you can create a lot of different things, because JavaScript is so versatile. You can make your experiences even more versatile when it comes to with respect to TensorFlow.js. For example, there are a few examples where, this is a person, Ricky, who has created this lasers cool demo by using WebGL shaders and TensorFlow.js. Then, for example, this is Jason Mays, who is a senior developer advocate at Google for the TensorFlow.js team, and he uses a wide variety of different things. WebRTC, that is used for real-time web communication. He uses A-Frame, that is used for augmented reality. 3JS, that is used for 3D rendering, and then of course TensorFlow.js to do all of these different things. And then we have this one again created by Jason, where he created a clothing size estimation demo using TensorFlow.js. And then we have again we can combine things like WebXR, that is uh, WebGL, that is used for 3D graphics, and of course TensorFlow.js to create these unique experiences. So that is the main power of using TensorFlow.js and using basically the pre-built models. And you can, because we have JavaScript as such a versatile language, you can use all these different techniques. You can use let's say library in JavaScript that is used for 3D rendering, and you can use that with the TensorFlow.js. Or let's say you want to use library in JavaScript that is used for creating a game, so you can create AI-based games using Phaser.js or P5.js. So you can create different combinations of libraries and use them with an application from TensorFlow.js to create very intuitive and fun applications in web. And the next part that we come on to is the transfer learning, that is essentially retraining your existing models with your own data, right? That we have already described. And how we achieve this in TensorFlow.js. So one of the most amazing tools that are out there is the teachable machine that basically does that transfer learning. So whatever inputs that you give to it, it can basically do it for images, for audio, and for poses. So the example that I'll be giving to you is via the image example. So let's quickly get started with that, because again it's a very, so you need to go with teachable machines dot with google.com. This is the website. By the way, if anyone has any questions so far, would love to take them up as well.
Yeah, sure, Shivay. We have some questions here. So
Sure.
the first one is not really related to but I'll just put that up. So this is by Red Spy and it says, I'm not a
Yeah.
computer science student. I am a statistics student. Any advice for him particularly or her?
Sure. So I mean, you are on the right path, because a lot of people they like to jump directly into the concepts of machine learning, but they don't really consider the major things that are happening behind machine learning. Because behind machine learning, so see, whenever we talk about any application of machine learning, everything that we have, like whether it is data in the format of images, whether it's the data is in format of text, audio, everything gets converted into mathematical format. So whether we are talking about NLP, that is natural language processing, and we have textual data, that gets converted into something that we call as word vectors. For example, images are consisting of pixels. Now these pixels are then converted into matrices and let's say arrays, which we call as vectors. So each and every different data that we have, it gets converted into mathematical representation, and we use a lot of different mathematical and statistical techniques. For example, in case of linear regression, we use concepts like covariance, variance, mean. When it comes to KNN algorithm, we calculate the Euclidean distance. Right. When it comes to neural networks, we calculate the Gaussian descent. Right. So there are a lot of different uh, statistical techniques when it comes to machine learning. So of course, as being a statistical student, you are learning all of these. So for you, learning some basic concepts of computer science, and of course learning a new programming language like Python or R should be a good stepping stone for you. And of course, with the statistical background, you will be able to actually easily understand all the different algorithms that are being utilized. So it's just about getting that hands-on exposure with things like programming languages, and for example things related to deployment, because if you want to deploy your machine learning projects, or you want to do research work based on that, so just learning some few computer science fundamentals should be a great start for you, and you can easily go through the different algorithms that are out there just with your interest and knowledge in these statistical techniques. So I guess that should be the best opinion according to me for you.
I think yes, that would definitely help as well.
Yeah.
And we have another question that says TensorFlow library is composed with which language?
So see, the core API, the TensorFlow core API has been built using C++. Now, of course, when it comes to C++, it's a low, it is a really great system level language which helps to create things like Python, Node.js. They have all been built on C++. So that is one of the reasons why it was built. So we use things like templates, abstractions in C++ that help us to create TensorFlow, but the TF library itself, right now, it has support for Swift, it has support for Python, it has support for R, JavaScript, TensorFlow like using Java. So today, like, it has support for most of the languages that are out there. And in case it doesn't, so you can still, like, use, like, let's say, a custom backend in Python and use that alongside whatever language that you're working with. But of course, the support and the growth of TensorFlow across multiple languages is growing on day by day.
I think that definitely clears up the question. We have another question from Bhuvnesh, which says he's actually researching upon AI and ML and DS2. I think that refers to data structures here.
Yeah.
So, could you provide me an official site so that I can get an idea from this? Maybe some reference to your website if you have.
Okay, sure. If you are researching upon AI/ML, that is really great. I think DS might be data science over here.
Yeah, I
If
was
he's
kind of
researching,
stumbling.
yeah,
Yeah,
you
I
can
thought
probably
upon
ask.
that.
Yeah. So again, a really great question, Bhuvnesh. And the idea is that in case you want to get started with AI and with ML, of course, the prerequisites that I explained to you, those are still going to be there. But usually, you can either go ahead by looking into certain books, or you can look at video tutorials, because these tutorials, they give you a guided path. You can also look at the Code for Cause machine learning 30-day boot camp that they had last year. And again, like, it is probably one of the best courses that you'll find on YouTube right now. So they also, what they did was, they looked at each and every different machine learning algorithm. They built it from scratch, and they had projects based on that. So even that is a really great learning resource. But apart from that, there are certain books that I would definitely recommend, and that is, I guess, the Skykit learning book. I'm not mistaken, machine learning book, basically. It is one of the best books that you can have a look at. So this is the O'Reilly author. I'll share the link for this for the Amazon book. This is quite probably one of the best books that you can have to understand things like TensorFlow,
Should I
scikit-learn,
share
and of
your
course
screen
basics.
so that people can
Yeah,
also see it? Awesome.
yeah, sure. So I'll also just share that in the private chat, if you can share that, right? So I'll just
Yeah.
share the link. But of course, this is the book that you can have a look at if you are more sort of a book nerd. But of course, if you are more interested in using, in learning about uh, through video lectures. One of the best ones that to get started specifically for AI for TensorFlow is this course by Lawrence Maloney. I can give like my 100% recommendation for this course, right? And of course, when you're starting out with machine learning, if you really want to truly understand the deep mathematics and how statistics comes into there, so we also have the machine learning course. Again, a really hugely popular courses also available on Coursera, and you can have a look at those as well at the same time. So these are some great learning resources, and of course, the documentation from you get from the main website. So if you go to tensorflow.org, obviously, like, the main documentation that you get from these, and the learning resources that you get from the website, like, that is, I always suggest to everyone that, if you're asking for resources, always do visit the main website of that technology or that language that you want to learn, because they always do have a lot of great learning resources. And like, you'll always find good content on such kind of. So for example, over here you can look at some core fundamental concepts about TensorFlow, on how to get started with TensorFlow, about deeply understanding, okay, how tensors work, what are the different types of tensor operations, right? So you can have a look at those as well. So I hope that gives some insight. But of course, all the different links, I would share them at the end of this session, and we'll share them across in the Discord community as well. So if anyone has any doubts, you can refer to
Sure,
those.
sure. So we do
Yeah.
have some other questions. So do you want to take them up now, or should we take them up after something?
Because I think I saw a few questions related to TensorFlow.js, so I would like to first just complete the TensorFlow.js part, and then we can take them up.
Awesome.
All right. Yeah. So basically, the next thing that we were going to talk about was the transfer learning using Teachable Machine. So Teachable Machine is a really fun tool that is provided by the Google team, and it can basically recognize your own images. And what happens is that internally it has neural networks that are being run powered in the backend, and whatever data that you give to it, it is being learned by that custom neural network models that you can also modify on your own, and they give you a prediction based on the input data that you provide to them. So to get started, you can either look at the current supported projects that are out there are for image based, then you have audio, and then you have post. So as a demo, I'll just show an image based one. For this, I'll just uh, you know stop my camera from my StreamYard. So we'll go over here. We look at the image model. So as you can see over here, like we know in machine learning, we have different type of classes. Now each class will have data that has similar properties, and this way, like we'll able to classify different types of objects. So classes are very popular when it comes to supervised learning algorithms, and image classification is what we're going to be doing over here. So each class will have unique attributes, and what we're going to be doing is that I'll instead use my webcam, and what I'm going to be doing is that I'm going to be distinguishing the data for images of my mobile phone, images of my let's say my mouse, and my mic. So let's get started with that. So for example, let's say the first class name that I give is images of my phone. Now what I can do is that I can either upload images if I have images locally stored, or I can use my webcam. As you can see, like the webcam has opened, I guess. So yeah, I'll have to use the Logitech. Okay, yeah. So now what I have to do is that I have to host my phone. I have to basically take my phone, and I'll click images of that. So you have to hold on record, and it is taking image samples, right? And you can try to use multiple. For example, let's say I take 113 image samples of my phone. Now let's say I take another one, that is, let's say, my mouse. Again, I will use simply the webcam, and again use the webcam over here, and again I will click on, let's say, record. So I'll hold record. I'll take, let's say, another 100 odd examples, right? And let's say these are good enough. And let's say finally I have another class that I have. Let's name this class as, for example, mic, right? So I'm just going to be using my mic. So this is my mic. So let's get started. So again, I'll use my webcam. For example, like let's say this is my mic. So I'll again, click on record, and it will, like, let's say we take around 100 images, right? So this way, what happens is that we have created our own data set of images, right? We have three different classes. We have the phone class, we have the mouse class, and we have the mic class, right? And now you can see over here, like it's just a simple button, press of a button, that is a train model. And what's happening, first of all, is that it is accepting the training data, right? Whatever training data that is it is having, it is preparing that data, and then it will feed that to a pre-existing neural network that is being run on the backend, being powered on the backend. And once the okay, so you can just wait for it. So once the training process starts, right, it will start the training, and as you can see, like it very quickly also just starts the training as well. So, and it's relatively quicker, right, as well. So what's happening is right now this pre-trained model is taking one image at a time, understanding its features, and then using those features to modify its weights, because neural networks have something called as weights, and the weights are the ones that decide which particular output would be generated. So right now that process is actually happening, and we didn't need to necessarily know that what exactly is a neural network or what was happening in that, right? It is doing all on it by just a simple click of a button, that is model train. And our model has already trained within a minute or so. So let me actually, now as you can see over here, we have three different types of outputs: phone, mouse, and mic. So now we'll test it out. So let's say I bring in my phone, right? And it says that it has 100% confidence that it is my phone. So the phone class gets 100% confidence. Now let's try to bring my mouse, right? So again, it says that it has almost 98 to 100% accuracy. And let's say I bring my mic. So again, it provides again 98, 100% confidence. So this way we have just created a simple image classification machine learning model. And the best part, we have not even reached the best part. Let me just close this output. You can actually export this model in TensorFlow.js or in, let's say, in TensorFlow Lite, or if you want to actually use, like, let's say, in Python, right? For example, this is just a Keras based implementation of the model. So you can import TensorFlow.keras and you can load your model and you can use that model, right? You can, so basically you can use this model anywhere, right, that you have just created. So for example, if you want to use this in JavaScript, you can just have a look at how small the code is. So the code over here, as you can see, that we basically have this file called model.json that describes the information about the machine learning model. Then we have metadata.json that describes things like the weights associated with the model and all those information. And then what we do is that we just load our model over here. We initialize our webcam. Then we find the data that we receive from the webcam. And then we use that inside of the function predict, where we start with the model.predict based on the image data that we're getting inside of the webcam. So we are first featuring the data, or we're collecting the data that is coming in from the webcam. Then we call it that data inside of this model.predict function, through which we are able to then run our our predictions. So for example, in case of the image classification model that we created, we had 3 different predictions. So we'll get like a prediction score for each one of those classes that we had. So you don't need to know any machine learning concepts, and yet you're able to create such powerful machine learning applications. And just to give a bit of a context, right, in case you are a bit more interested in knowing more, as you can see that you can actually change the number of epochs. So number of epochs are the number of training cycles in a neural network. Then the batch size, learning rate, these are all very advanced concepts inside of neural networks as well. So you don't need to know about any of these, and you can create your own machine learning model. And if you also want to know like things like, okay, what was the accuracy per class, what is the confusion matrix, what is the accuracy after every epoch, right? Epoch, again, the training cycle, and what is the loss, like what is the accuracy loss that is happening after every epoch. So this gives you a much more comprehensive idea of what is actually happening. And in case you don't know about what exactly are neural networks, how do neural networks work, what is epochs, what are accuracy curves and loss curves, you're able to understand how it's actually functioning, and you can modify this according to your own needs based on this data. So this is the power of the teachable machine. And you can also use teachable machine to create really great machine learning models. Whether if you have, like, let's say, so an example would be that you want to create a social project that helps you to distinguish between different types of wastes. So let's say you create a machine learning model that has 100 or 200 images of different types of wastes, and you can create that model using the teachable machine and then use that in your application. So this gives you a very intuitive way of creating machine learning based models. So I hope like this gives an insight to everyone. If anyone having any, yeah. So now basically we have the teachable machines, right? And apart from the teachable machines, we also do have things like cloud AutoML. Now, the one of the I would say the drawbacks with the teachable machines is that with teachable machines, the amount of like data that you can actually train is sort of limited. So if you have like data in gigabytes, you'll probably be better using something known as cloud AutoML, that is part of the GCP. And of course, where you can actually train these custom vision models in the cloud and then directly deploy them to TensorFlow.js. So if you have data in gigabytes in size, you can use things like cloud AutoML for that as well. So if you have any like major have data of, let's say you want to create like a let's say if you want to create a machine learning algorithm that is able to distinguish between different types of skin diseases, right? So probably you might be having data of images of skin, right, in gigabytes. So you can use that, and again, it will be hugely popular, right? So I hope like that makes sense to everyone. And then we'll move on to finally, so first let's actually understand this code as well, right? So as you can see in the first couple of lines, right, we have the we have imported basically our TensorFlow library using the script tags. So this is like in HTML, right? And we have imported both the TF min, that is like our main TensorFlow.js library, and also we have imported our AutoML one, because we are going to be using an example of image classification. And we have defined an image ID with Daisy. So we are going to be providing, and like we have provided an image of a Daisy flower. And then if you look at the script, right, in just 4 lines of code, we are able to predict that, okay, what is the type of flower, or what is the type of image that we have. So as you can see that we create an async function. The reason that we create an async function is that in JavaScript, the model can take some time to load. So we don't want our other APIs or our other lines of code to actually start running before our model is loaded, because if the model is not loaded, then it will throw an error. So we use an async function where we first call the machine learning model, and once the model has loaded, then we start using it. So just look at those 3 different lines of code over here. One is the const model, where we define our model, and over here we have used async await, where we wait for the model to load from our model.json file, and we are specifically looking at the image classification model. Then we define our image, and we use the get element by ID to fetch uniquely the image of the Daisy. And then we run our predictions by using model.classify. So we are using a classification algorithm. So we use the classifier function, and we are able to get our predictions from that. So just by using this 4 lines of code, you're able to create an image classification model, right? So this is the power of TensorFlow.js, and how it actually makes it super easy to create machine learning based algorithms and basically use machine learning in JavaScript. Then of course we finally have ability to create your own code, and that basically is using something like the high level layers API that is built similarly to how Keras has been built on top of on TensorFlow. And we also have the ops API that you can do mathematical calculations like linear algebra, all of that stuff using the ops API. So essentially this is how our architecture looks like. We have the pre-built models on the top, right? Then we have the layers API, and finally at the base, like if you want to go into the custom implementation from scratch, that is where you can work with the ops or the core API. And basically you can run this on either the client side or on the browser side, because on the client side because our browser basically runs on the client side. So JavaScript client side also has a great support for TensorFlow.js, where we can basically run our models or power our models using the CPU or WebGL, that is web accelerated graphics, or WebAssembly, that is another way to host the custom client side machine learning models. Or you can have on running it on the server side in Node.js with the TensorFlow CPU or the TensorFlow GPU. And basically, as you can see, like the layers API is synonymous to the Keras model, right? And then we have the cores API, where you can actually write your own code in JavaScript natively, or you can use something like the TensorFlow.js converter that helps you to actually convert a model that has been written in Python and directly use that in a JavaScript based format. So it converts the saved model in Python and converts it into a model.json file, metadata.json file, shards. Basically, there are various shards that get created that are essentially the weights, right? And you can use that directly into your JavaScript file as well. So there is the TLS converter as well being used. And of course, one of the biggest question that comes up, that is the TensorFlow.js actually equal in performance to the Python-based models. And as you can see that we are using MobileNet, which is a very popular model, and you can see the inference times were actually quite similar for both TensorFlow having written in Python and in JavaScript. And in certain cases, it actually outperformed the Python version. So this is an example of BERT, which is used in NLP. BERT is a very, very famous Python machine learning tooling that's used in NLP. And we can see that with Node.js, it was actually giving us 30 to 50% better response time. And some of the major reasons that why one should actually use TensorFlow.js in the client side is because, of course, it provides you privacy. Because we are not having like a dedicated server, so your data stores or is being stored locally in your client side only, and there is no dedicate, like it's being dedicatedly stored in the client side. There's no interaction with the offline server, right? Because normally what happens is that in case your data flows from your client side to a server that is hosted remotely, there's always a chance that some middle attack might be able to take place on that data. But since the data gets processed and stored locally in your browser itself, that is why there's a lot of privacy when it comes to the client side rendering. And of course there's lower latency because there's no network delay in terms of sending and receiving information. So whatever you do immediately gets reflected onto the site, right? And then of course we have like a lower cost because we are saving the cost of actually creating servers. Then of course it is also quite scalable because again we are not really having like a dedicated server, so everything happens with the help of resources from your computer. And but again there are certain advantages of using Node.js as well. So we can write our own machine learning model from scratch in JavaScript. Now, TensorFlow.js, like Node.js, also has this concept of just-in-time compiler that does help a lot with the performance because you get immediate results using the just-in-time compiler. And of course, you can actually run much more powerful models using the Node.js with the help of the TensorFlow GPU, TensorFlow CPU, because there are certain restrictions on the client side. So if you are running very much more heavier models, you can use the TensorFlow.js in the backend as well. So I hope like that is clear to everyone. And of course, some of the good resources to get started specifically with TensorFlow.js include, going to the website that is tensorflow.org/js. We'll also get a lot of learning models, right? And of course, if you are a book nerd again, this is a really great book that is by manning.com/book/deep learning with JavaScript. This is a really great book if you're interested in TensorFlow.js. And of course, you can go to TensorFlow, github.com/TensorFlow/tfjs if you are interested in the GitHub code. And you can look at some of the code examples on CodePen and Glitch, right? And of course, right now we'll just have a quick look at some of the code examples ourselves as well, based on some of the examples that I had created. And this way you will be able to see how to get started by introducing those code in our systems. But apart from that, like there are a certain number of other things that I would like to also talk about in terms of the community and how you can join the community and get started with the community as well. But before that, I would love to take up some additional questions if there are any questions. I have to take up some questions
Sure,
on
sure.
that.
We do have a lot of questions. We do have a lot of
Yeah.
OPs and OP for you as well. That could be from Karthike only. So Karthike,
Yeah. So interestingly, Karthik is going to be. So I'm a co-mentor for the TensorFlow.js project this year for Google Source Code, and Karthik is the student. So huge shout out to Karthik as well. So I'll be working with him during this summer on the TensorFlow.js
yeah,
project in Google Source Code. So
that's amazing.
yeah.
Awesome. I think we do have some other questions. We'll just take that up quickly. So one question is from Harshvardhan, which is TensorFlow or does TensorFlow work on every single platform?
Yeah, so again, this question is sort of revolving around the support for TensorFlow.
Hmm.
So as we described right now, that we have a great support for creating Python-based TensorFlow models and projects, right? So those are all your Python related, and you can host them on using Django. Then you have TensorFlow for JavaScript. You have TensorFlow for Swift that you can use for creating iOS-based applications. And also you have MediaPipe and TensorFlow Lite that helps you to create low-powered TensorFlow models for devices like, let's say, your watches, smartphones, right, for doing on-device machine learning or creating machine learning applications. So these are low-powered. They're less likely to consume a lot of processing power as well. So that is a great way. And of course, the support is also increasing. Recently, we had TensorFlow for quantum computing with the TensorFlow Quantum introduced
Hmm.
somewhere late 2019 as well. So the support is actually growing, and right now you might not directly have support for system level programming languages, but of course for that we have things like MLOps that can help create workflows. And TensorFlow again has really great support with Kubeflow as well, that does create ML pipelines, ML data pipelines for ML operations. That is MLOps basically using Kubeflow and a lot of other tools. So I would say like there's great support for TensorFlow for most of the platforms.
Awesome. So another question we have is that do we need any dedicated GPU to train models using TensorFlow?
So that depends on the amount of data and what kind of problem that you're trying to solve. So we have support for both TensorFlow CPU and TensorFlow GPU, because majority of the students might not be having like a dedicated GPU on their systems. So when you're installing TensorFlow locally in your system, it gives you the preference to either install like a build of TensorFlow without GPU support or with CPU. So you have that option while you're trying to install. So again, you have to go to tensorflow.org and you can look at the documentation for installation process. So the first thing that you have to install is Python. Then you can install using pip, the pip command, that is the Python import package manager. Like, it helps you to import any and download any Python packages and libraries. So you can use that. Yeah, on tensorflow.org you can find the installation steps as well. So that will help you to use either CPU or GPUs. But of course, if you have a very large data set, or you're building something that is actually quite large, then in that case, of course, having a GPU support will help to actually accelerate. And we also have, apart from GPU, we have something called as the TPU, that is Tensor Process Unit. So this was especially, like, these are specifically dedicated hardware that was created by Google specifically for machine learning workflows involving TensorFlow. So if you use an online tool, so I would like to share that as well. So that is basically collab.research.google.com. So you can use TPUs over here as well. So basically, Google Collab is a tool where you can create online machine learning workflows. So it essentially is IPython notebooks. If you have used the Python notebooks, you will actually find the usage of these Google Colab notebooks also quite similar to how the Python notebooks look. So over here you can set up your own support, whether you want to use the CPU or you want to use GPU or you want to use TPU. So Google actually provides you support for cloud-based support, and so based on whatever thing that you're solving, right, if you want to accelerate that process, you can use a dedicated GPU or a dedicated TPU, because a TPU might not be useful in all cases, but there are a lot of different applications in TensorFlow where TPU will actually, so you can go to runtime and you can actually set the runtime type. Right now, by default, so you can see this hardware accelerator, right? So you have support for GPU or for TPU. By default, it will use the CPU. But if you want to have a hardware accelerator to further do the calculations and run, or basically further faster the process of the machine learning training, you can use a hardware accelerator by using like the GPU or the TPU as well inside of this. So when you're, like, let's say if you're creating a project in using the Google Colab, you can also use the TPU as well.
Awesome. Okay, so Mayank asks how much depth of knowledge is required for contributing to TensorFlow.js, and another person, Prathamesh, also had the same question. So it would
All
be
right.
great if you can answer this.
So, man, like, this is a completely a question that is dedicated to how one can contribute to TensorFlow and TensorFlow.js. And for that, I would like to also, combine the question of how to contribute to TensorFlow as well. So I would like to sort of mix both of those questions, and that is what I would like to, also show. So basically, the best way to contribute is, you'll find the best documentation about that by going into tensorflow.org/community/contribute. So this is a really great way to understand how you can contribute, because you can contribute not just on the basis of like through code. We'll go over the GitHub as well, and we'll go over quickly on how you can do that, right? So either you can contribute to the documentation, to directly to the code, or to the community, because the community in TensorFlow is really active. We have special interest groups that are SIGs, SIGs, right? Basically, that are for TensorFlow and specifically dedicated for TF Lite, for TensorFlow.js, for TensorFlow, that you can join, and you can do that. Or you can contribute to the documentation, because TensorFlow documentation is one of the most important things for a lot of beginner developers. And of course, you can also contribute directly to the code by going over to the github.com/TensorFlow. So you'll find a lot of different TensorFlow based repositories. So for example, the TensorFlow is the official TensorFlow API that has been built, right, for C++, built using C++. Then we have TF Lite, we have Quantum, we have Java, embeddings for Java, basically, right? we have datasets. So TF dataset is a great way to contribute via code and via documentation. So datasets like TensorFlow datasets is like a single repository. You'll find a lot of common datasets that are used for things like diabetes prediction or coronavirus prediction. So of course, like you'll find a lot of different unique datasets as well. So you can contribute to any of these projects. And some important things to keep in mind is that, of course, like with any open source contributions, go and select the project that you like, and of course you can look at some of the beginner friendly issues, right? So for example, if I want to contribute to TFJS, there will be a lot of different open source issues that are there in TFJS, and I can select by going into the label if there are any good beginner friendly, or let's say good first issues, right? So probably I might be able to actually find one of them, right? So some new features, right? Some beginner friendly, so you can look at those, and you can look if no one has implemented, like if there is no assignee, you can understand what exactly is the issue, and you can implement, right? You can contribute. So this way you can also contribute directly to the code base. Or what you can do is that, for example, if you're not very confident enough to contribute directly to the code base, what you can also do is that you can create examples, right? So a really great example that I would like to specifically give huge shout out to is Rishit Dudley, who is from the TensorFlow community as well, and he has created really wonderful TensorFlow.js examples. So he's a really great person in machine learning, and he has created, and that is why we have a dedicated repository for the TensorFlow. I guess it's part of the TF.js only. We have specifically for examples, right? We have specifically a lot of different examples. So you can go and look at those TensorFlow.js examples as well, to have a look at how, if you don't want to directly contribute to TF.js, right? You can create create an amazing project and contribute that, so that people can use that, or people can take inspiration from that. So you can either contribute directly to through examples, or directly to the code base of TF.js, or let's say you can take sessions on TensorFlow.js to further advocate about it, right? Those are the ways in which you can contribute to TensorFlow and to TensorFlow.js.
Awesome. So we have some questions regarding the teachable machines model that you were trying to depict over there. So we have some questions related to that. The first one is, does clarity of image matter for the data?
Yeah, I mean, it definitely does, because of course, if you have a lot of noise in your data, then it can reduce the accuracy, because the features that you're trying to find from each and every different data item, if we do try to reduce the noise, and we do try to reduce that is where the data cleaning process comes and normalization techniques comes in. So of course, if the data, like if the images are more clear, it can help, but of course we do have techniques through which we can super resolution, in which we can improve the resolution of the images as well. If you have that in the pipeline, that can improve. But of course, with the teachable machine having a better clarity in the picture, but no, because today you have modern webcams, right? You're not going to be using
Right.
a 20-year-old webcam, right? You don't need to do that. You're not going to be having like a 54 like 154p image, 144p. At least everyone has a 720p camera, so 480p camera, and that is well enough to get started with. So I hope that makes sense.
That definitely does. A similar question, which is, Lens Studio works on TensorFlow or something else when we talk about image processing and matching?
So Lens Studio is this. Are you talking about the Snap Lens Studio? Is Harshvardhan, is that what you're talking about?
I
So
think he's
Lens
in the
Studio,
chat, so he'll just reply to that.
yeah, yeah.
Otherwise, you can take this.
Yeah, if I can just get to know, because Lens Studio, I've heard it's the Snapchat. They have created this, and that actually creates a lot of effects of augmented reality on by creating,
Okay.
like, let's say, snap filters, right?
Oh,
So
I get it. So, like,
if
there are some weird emojis all over your
yeah,
face. I think that, yeah, I get it now. Yes, I think he's talking about that.
all right. So Harshvardhan, I'm not exactly sure, because when it comes to image processing, you also have PyTorch, and they haven't really released their code base. So I would assume that yes, it does use either one of those, right? Either TensorFlow or PyTorch, because PyTorch is a open machine learning open source framework created that was released by Facebook, and even that is quite popular when it comes to computer vision based applications. So it would either be one of those two if I have to guess.
Okay, cool. We have one question from Anshuman. So he asks, code automatically. So does the code automatically generate while training the data set?
So I would assume that this would be with regards to
The teachable machine.
the teachable machine, right?
Yeah.
So see, what happens in these models is, right, that the model code in itself is already there. So the as I said, that they use neural networks as their backend in teachable machine. So whatever input that you're giving, we are just retraining our model. We are readjusting the weights of the model to train and adjust to our new data set. So code in itself is already there, and what we get out of that is that, as you saw, that there were predefined codes for Keras implementation, for the TensorFlow.js implementation. We just generate a new model.json file or an H5 file that has information about the type of model, how many number of hidden layers are there, how many epochs are there, like that general information, and then we have information about the weights, so that we can directly use that model and use it for predictions without any other training.
I think these are all the questions that we had. We had something from Karthik. I think it was not a question, it was something more of what you were trying to refer about TensorFlow
Exactly.
GitHub repository.
Yeah, so
Yeah.
Karthik again a super huge supporter. So you can use a hashtag made with TFJS these on platforms like LinkedIn and Twitter to find great, amazing TensorFlow JS projects as well. But of course, another point that when it comes to how much knowledge do you require to implement TensorFlow JS? Now that can be as simple as, you just know simple HTML, CSS, and basic JavaScript, and you can create, let's say, you can use the pre-built models to create simple applications. You could learn things like WebAssembly as well, that use mscripten and C++, having knowledge about C++, and create your own machine learning models that are powered using WebAssembly or, let's say, WebGL. So you can go really deep into it as well. Of course, you can create cross-platform applications or applications built on React, Vue, and you can have support for. So you can have knowledge about those as well. Or let's say if you know about Node.js, you can create those kind of models that are powered using a TensorFlow node, right? Using TensorFlow CPU or TensorFlow GPU on Node.js as well. So like you can go ahead and use any of those, and you can create your own custom models directly in JavaScript with the TF ops API, right? So that, just if you have like knowledge about great knowledge about machine learning, you can use those concepts directly while creating the TensorFlow ops API model, and that is the level to which you can go. And of course, if you want to contribute directly to the official TensorFlow this like to the code base, if you know some basic C++, TypeScript, you can also actually contribute to that, understand how things are created over there, and you can also contribute to the code base. So it just depends on the level of experience that you have, and that way you're able to use them. So I hope like that
So
makes sense.
yeah, that definitely does. And so Harshvardhan is basically asking if it would be possible to give them the link of the GitHub repository, link of TensorFlow.js that we were
Sure.
referring to about.
Yeah. So I'll be sharing this slides. I guess you can also again share the screen. So
Yeah,
all the different. I'll share this link of the slides, right? Probably I'll do it at the end, or you can do it right now.
sure.
That's totally fine. I'll do it right now. It's fine.
No
So
worries. Whenever, whatever, like is more comfortable with you, we can do that. And
yeah,
yeah, I
of
think we
course.
are done with all the questions.
I just had a couple of different things that I just wanted to take note of, and I guess that would be
Sure,
enough.
sure.
But of course, yeah. So apart from this, right, as Karthik had already mentioned, that do follow the TensorFlow.js, hashtag, right, made with TFJS basically, to find really amazing projects, right? All these different projects that you see have been built using TensorFlow.js. and you'll find really amazing projects right now. And if you go to the community section, and there is specifically like this website called dev library with google.com, which will where you can actually see a lot of different amazing projects in machine learning and in TensorFlow, and you can see these projects live over here with their GitHub repositories, with their GitHub links. And again, Rishit again has he's part of this, right? So you can use this as well as a resource to look out for some awesome projects, and um, this way you can also get used to it. But apart from that, like one thing that I just wanted to also some good learning resources. Of course, these are the ones that we have, and of course within Coursera, right? We I forgot to add that, of course, but you know. The major concepts that you'll learn, of course, before getting started with TensorFlow, of course, you also do need to keep in mind that if you have some experience with machine learning beforehand, that will definitely help you out in doing TensorFlow. But of course, when it comes to TensorFlow.js itself, right, you don't need to know machine learning at all, because you can use things like the pre-built models, and those pre-built models, they simply just have like a dot predict function, dot train function, dot classify function that I can use directly, right? And that will help you get started with TensorFlow. So I hope like that makes sense to everyone.
Definitely. I think you can also share this resources slide, because
Yeah,
I think
sure.
people would also be asking for that. So it would be
Yeah,
good if you
absolutely.
can just
I'll
share
share
that.
that after this one.
Definitely. So are you sharing
All right.
something else, or like should I share your screen?
Yeah, so basically just with TensorFlow, there's like, it's just that machine learning is for everyone, right? And it's just whatever you make, you do share that, right? And of course, if you want to stay in touch with me, you can also like connect with me on my Twitter. I'm usually more prominent on Twitter, so you can connect me on Twitter on how develop. You can follow me there. In case you have any question, you can reach out to me through the messages, because I'm usually more usually more active on the Twitter, right? But if I'd love to take any other additional questions if someone has.
So I think we are done with the questions. We don't have a lot of questions after, because we were trying to cover them all between the session as well.
Yeah, yeah,
So we had a bunch of them, but we got them cleared. And I think
absolutely.
so. All of you, if you want to collaborate more, or if you want to get in touch with Shiva, you can definitely go and check out his social media handles on Twitter. That is from How Develop. It's also mentioned there on the screen. And
And one thing,
also you can.
I'm sorry to interrupt in between, but I absolutely forgot. So one important tool that you can look at is Code Labs. So basically, Code Labs are a great tool for anyone to get started. So whether it's trying to create your first ever TensorFlow program, right? You can filter over here by category. So for example, let's say if you only want for AI and web, so I can go over here and I can look out for TensorFlow only, right? So you'll find a lot of different TensorFlow related, like how to get started with TensorFlow, right? How to build like a computer vision model, how to get started with TensorFlow, right? Similarly, you'll find like TensorFlow for Keras, TPUs, create like a
Right.
custom text space. So these basically provide you like step by step, step by step format through which you can get started, and they provide you relevant information, right? So for example, let's say if I want to look out for specifically for TensorFlow.js, so I can simply just type in TensorFlow.js over here, and you'll find a lot of different code labs that are just dedicated towards TensorFlow.js. Let me just, I think my screen resolution might have just changed a bit, but okay. So you can
Yeah.
yeah, so you can search, so like if you can search literally for anything, right? So for example, if I want to search for TensorFlow.js, right? So I can, for example, if you want to learn TensorFlow in Node.js, right? If you want to build like a custom spam detection filter, so you can do all of these different things, right? So if you want to look specifically for TensorFlow core, let's say, if you want to learn specifically about the TensorFlow core APIs and how they work, how to basically create TensorFlow, right? You'll find those over here. For example, we spoke about the TFJS Python converter, like TFJS converter. This will show you how to convert a Keras based model into a TensorFlow.js model as well. So you'll find a lot of relevant code labs which you can take a look at, and you can use these to learn the concepts as well.
Awesome. And someone says that they really appreciate your beard and hairstyle.
Yeah, that is the pandemic effect.
That is a work from home style we all have adapted to now. I think until now we all have adapted to this work from home pandemic effect.
Yeah.
But thank you so much, Shivai. It was amazing having you and hosting you as well. And
Thank you so much.
I think the session was wonderful. We even have still 10 people, 11 people there, so that definitely means a lot that people are still
Yeah.
glued to the screen and they can't obviously leave the session like that. And thank you so
Yeah.
much
Yeah.
for because that definitely goes up to your approach. I thoroughly enjoyed the session, and I hope all of you did as well. And if you'd like to connect with Shiva, you can definitely go and check out his Twitter and LinkedIn profile, and you can connect with him over there. And for all the people who are still there, definitely we have the participation certificate for you all. So make sure before leaving this, you can just I've also shared the link of the participation certificate in the comment section. So you can just go and check out this and you can fill this form to get a participation certificate. It might take some time because the hackathon is also closed. We are
Yeah.
just 1 week away from that. And also, if you do want to connect more with Shivaya for this particular hackathon, he's also coming there and collaborating with us as a judge. So
Yeah.
if you would like to even collaborate more, so you can definitely check out HackCon. It's there in the description box as well. And do register because it's just a week away. And thank you so much, Shivaya, for
Thank you so much.
joining us.
Yeah.
It is a great pleasure for us as well. And we'll
Thank
end
you.
this stream now. Thank you, everyone. We'll meet you soon. We have another session tomorrow. So we'll meet you soon then. Bye, everyone.
All right. Thank you so much.